Okay, so let's do office hours. Let's do office hours / problem solving stuff. Woo! Anyone have questions? Why is the sky blue? Yeah. I've been instructed once on a review session, if no one asks questions, that I talk about for 75 minutes why the sky is blue.
Don't do it.
Yeah, I won't do it. Why the sky is blue. It's interesting, but it's not related to regular or context, whatever languages. Yeah.
Quick question.
Yeah.
For problem 1, the hint to reverse the strings and then
Yeah.
we're not. That was a hint to get us there. We don't have to prove.
No. Yeah. So you can just present a DFA and literally nothing else, and that's fine. But it's just it helps you get the idea going. Yeah. Because we add numbers in the reverse direction of what the DFA would read anyway. Yeah, so reversal would help, yeah. Guys, shh. Yeah. So, so this is problem P set 1, question 1. So do you need help on how to do addition? No, I'm kidding. I'm absolutely kidding. So let's think about what possible inputs would a DFA see. So what I'm going to do is, so people watching at home will be able to see this, but a DFA, in terms of formally, the characters are 3 tuples, but I'm going to think of them as vertical columns. So we're trying to add the first row with the second row to get the third one. So we may get 0, 1, 1 as the input. So I'm going to represent it like this. So should I accept this input?
Yes.
Yeah, why?
Because 0 plus 1 is 1.
0 plus 1 is 1. No issues there. What about this input?
Not yet.
Not yet, right? If we were reading it backwards. Yeah. Not yet, because why?
Because it would need an extra.
I need a carry bit. Right. So we would have a carry bit here to note ourselves. And so we have a carry bit. Let's say that we have 0, 0, 1. Should I accept this?
Yes.
Yes, because with the carry bit now, 1 plus 0 plus 0 is 1. No issues there. So think of this. I may have a carry bit with 0 carry bit, or 1. Could I have more? No. That's something to think about. I only have 2 possibilities. Okay, does that help? Well, it's recorded, so I hope, yeah. You were asking. You'll need at least 2 states for that reason. But to answer your question, when we read, so we're reading right to left conceptually here. So because of the reversal thing. If we read that first character, so if we read that much so far, then so far, should we be in an accept state?
Yes.
Yes, because so far it's a valid addition. Correct? 0 plus 1 is 1. So
that was the end of the string right there.
yeah, if we just stopped right there, we should be in a final state. Correct. What if we read one more character? So ignore the first line, now the second one. Should we be in a final state now? No, because we now have a carry bit left over. But now, if we read the rest of the input, we should be in a final state. So now you just have to think, as I'm seeing this input, Do I have a carry bit or do I not have a carry bit? Think about this. So this is a totally separate example. So the first character is 001.
So yeah, that's something, it's not, when we're getting the input, it is the entire triplet, it's not like.
Yeah, so each triple is a single character.
Okay.
Yeah. So consider the example on the right. What should I do now? Does it matter what I read else? No, because no matter what, it's not going to be correct. So, but let's make it correct and cause a problem in a second. So that's correct so far? Yeah. And then, actually, let's have a carry bit to start. So we have a carry bit here. So let's say we have 1, 1, 1, which is a possibility. No, let's put a 0 in the middle to make things interesting. Should I accept now? Or what should I do now? I should go to a dead state. Because no matter what happens after, the string will never possibly be accepted. It will never be a valid addition. Because 1 plus 1 is not equal to 1 when doing binary addition. Okay? So there are 8 possibilities. Either 0 carry bit, 1 carry bit, I'm doing this for a reason, or dead state, and 8 possibilities each. So think, if you have a 0 carry bit, what things could I see to stay with a 0 carry bit? What things will take me to a 1 carry bit? What things will, after I read it, will I never accept? Okay? Something to think about.
So to be clear, I can completely remove the reversal proof. And just not
Yeah, you can remove the reversal proof, but you should at least give the grader an explanation of how you came up with the DFA.
So I just want to be clear, because I believe you said it, and that kind of tricks up my brain here. So, for example, W equals 0, 1, 1, 1, 1, et cetera.
Yeah.
That's a complete input. That's not.
Yeah, it's a complete input. Yeah. yeah, the input's always complete, quote unquote, but it may not necessarily be a valid addition, of course. Okay? Yeah.
I have a question about problem 5.
Problem 5, okay.
Yeah, like the last part, we're trying to prove that the two languages outputted by output DFA and output star DFA.
Yeah, are the same.
Yeah, what do we mean by the kind of the same?
So every output DFA is has the language of some output star DFA and the other way.
Oh, so we can construct.
Yeah, so equivalently, if you have an output DFA, could you make an output star DFA? And the other way around. So it's just like proving NFA's DFA's equivalence, but with these things. And it's noticeably easier here. But the idea is proving that they're equivalent by going both directions. Okay?
And for the regularity proofs, which type of proof is it? It's kind of,
So if the problem set says prove that language is regular, what do you do? DFA, NFA, regex, or regular grammar now?
okay.
Okay.
We can use the grammar now.
Yeah, I wouldn't recommend it though, because it's essentially equivalent to directly translated from an NFA anyway. So I would just go DFA or NFA route, or regex if you're crazy enough. Yeah.
For question 2, I rationalize this myself, I want to make sure if it's all right. Would the L3 ask for where W is a ternary representation of an integer multiple of 4? So any 3 substrings within W, or is it on every third input it essentially would check?
So if I look at the input, I'm interpreting this as a no, it's not. That's not base 3. I'm interpreting this as a number in base 3. and I'm asking the question, is it a multiple of 4 or not?
Okay, so that can keep. All right, so it's not. All right, I got it. That
Yeah.
changes my entire thing. I was thinking just every 3 you
No,
would
no.
read if it was one better.
No, I would have to be clear and say that every substring of length 3 is one of these. And that was actually one of the daily exercises. Every substring is one of those. Yeah.
So continuing with question 2,
Uh-huh.
like once you start doing the product construction, like it's very large.
Yep.
I know on CSE you talked about writing a program,
Mhm.
but what if you have no idea how to write that program? Like, what resource can we use to like?
You use an existing library. There are hundreds.
Yeah.
In fact, I use one.
You just,
So,
like, look up product
search on
construction
GitHub.
library?
DFA.py or whatever, if you're inclined to use Python, or .java if you want to use Java, or library to compute product construction. There are hundreds of libraries on GitHub. Use them,
I tried using the
or program it yourself. Yeah,
using the tables and using Excel.
or use tables in Excel. Either way. No, I think she was asking about like, is such a large table is tedious to actually do the calculation.
Yeah, if you're good with Excel.
If you're good with Excel, yeah.
So it's probably a good idea to do it at least once, right?
Or at least do a few of them, yes. Or, yeah, so I'm actually working with, I'm trying to implement an algorithm in a paper right now. And the number one thing that I recommend people is to understand an algorithm, implement it yourself. Yeah, because by several algorithms that I had no idea what they were actually doing, I implemented them in Python. Now I completely understand them, or somewhat understand them at least. But at least have some idea of how they work. I guess, does that answer your question? Okay.
It might help to look at it as it is an algorithm, so each one of these steps can be done on its own. So just solve it step at a time in your program.
If you're using Python, itertools.product. Yeah, itertools library in Python is my savior, frankly. Combinations too. That's also.
Well, question 1, why did it say that 001 is should go to
So 011 you're saying. 001. So I'm assuming that's the first character, or we have 0 carry bit. So 0 carry bit so far. 011. No, sorry, 001. Is 0 plus 0 plus 0 equal to 1? No. So would anything after that remedy that, though? Would the addition be valid if I read more characters? No. So therefore, I'll go to a dead state. Okay? Yeah. Question 3. Yeah, the product one. No, NFA. I didn't hear you, sorry.
Could I like run through how I constructed it and see if it's not completely wrong? Is that allowed for the session?
And constructed the DFA? Sorry, the NFA?
Yeah.
Well,
Like a general knowledge.
well, there are actually quite a few Piazza discussions on making substrings of things.
I think that all of them, I guess.
Okay, there were quite a few examples, and there was actually, I think there's a general construction on how to make recognizing a single substring and then use union for NFAs. Yeah, it shouldn't be too hard to make the NFA part. Yeah, you were first.
So I can make my DFA for number 3 and then make my transition table. I'm kind of stuck in how to translate a DFA transition table to an NFA transition table.
The other way. You made an NFA transition table, and now you want to make a DFA?
Oh, no, I made the DFA first.
Well,
Oh, no, wait. No, wait. NFA.
Yeah. Well, because
I made an NFA yet.
yeah,
Sorry, NFA
yeah,
transition table.
yeah. So what's the question?
And I'm trying to convert that transition table for the NFA to a DFA.
The
I'm kinda stuck in how to do that.
power set construction.
Power set construction.
Use the build your states method as we've done in class. So you figure out what the Epsilon closure of the start state is, and then figure out where you go on each individual character, and then do Epsilon closure of that and repeat until you can't get any more states. Yeah, it should. I think I got around 23 states
For your DFA?
for the DFA
How?
because I wrote a program to do it.
Okay, mine was a lot, like 4,000. Well, that's the possibility. but
Because you're making every single state.
yeah,
You're making 2 to the something
yeah,
number. Yeah.
exactly.
Oh, I'm a little confused on the difference between like a substring and a subsequence.
Okay, great question. So I think I covered this on Piazza, but it's worth repeating.
Every subsequence is a substring.
Yeah,
I mean,
no, every substring is a subsequence. So a subsequence is a more general definition.
You said 23 states and that previous the minimum set of states
I don't know what the minimum is
for number 3.
for number 3.
I
Yeah. So the way we'll probably grade those is based on, partly based on if you accept or reject certain strings, and then rest of it based on like if you gave a description or not or something, based on the question. So substring versus subsequence. So subsequence is a sequence of indices, I1, I2, and they're in sorted order. Let's say there are k of them. So that's the only definition of subsequence. And substring has I1 equals I2 minus 1, I2 equals I3 minus 1, etc. Yeah, you had a question.
Yeah, on number 4.
Uh-huh.
Or wait, am I jumping around? Yeah, no, number 4.
Mhm.
I just want to make sure I'm reading like, as I would call them, the mathy terms, right?
Mhm.
And when it says consider language SL, the first half is saying X is an WXY is an element of L, such that W and Y are like stars, so they're like random terms, and then X is there, and then Y is
Yep.
random terms. And then the other half is saying W is an element of L, and then X is somewhere in W as a subsequence, right?
Yes, it's how it's written on.
Yeah, so then we'd have to each prove one of those. We'd have to prove those.
Yeah. So you'd prove each one's regular, then closure under unit. That should be best.
And there was correction, right?
Yeah. It turns out that either way, it's still regular. Yeah. So I'll have a solution for both if people who aren't here don't know that an update has been made.
Either way are.
Yeah. So if we consider all the strings W and L and all the strings that have W as a subsequence, those are called the supersequences of L. And that's also regular, but you can also consider all the strings in L and consider all subsequences of those strings. And that's also regular. So I'll provide a solution for both. Yeah. Yeah. So if we got off track. So let's talk about
This helps us solve the problem too, right?
3.
4.
Oh, yeah. This 3 was something else. All right. Q4. So let's consider this string. Is BDBC a substring?
Yes.
Substring. No, because each of those elements is not adjacent. But is it a subsequence?
Yes.
Yeah, because, so this is no and this is yes. Because each of the elements in BDBC is in order in the original string. So there are a lot more subsequences than substrings. So the informal way of saying this is that a substring is just a subsequence where everything is adjacent to each other. So like for example, A, B, C, C, D. Is that a substring? Yes, because it's adjacent elements in the sequence. They're all adjacent to each other. And is it a subsequence? Yeah, because it's a substring, it's a subsequence by definition.
the difference is in the subsequence, there could be other characters.
Yeah, there could
They
be.
still have
Yeah.
to be in order. and
Yeah, they have to
the
be-
exact same number.
No, they just have to be in some order. They have to be in the order of the original sequence. So in this case, as long as they're in the same order as the original string is, you're all set. Yeah.
So as an example of not being a subsequence, B8 would not be a subsequence in this instance.
Correct.
Okay.
That's bad. That's good. That bad is not a subsequence.
Do you use like concatenation to kind of prove this table, or is that just a that's the route?
The problem might be if L is infinite. Unless you, depends on how you did it, but that is, concatenation is involved, I'll say.
Okay.
Yeah. Actually, I'll try to address some concerns with this. So if we have W1, W2, W3, whatever, Wn, in the language, and we want to consider all, let's say, super sequences of this, well, what can go in between or before or whatever each individual character? Anything, right? That could be useful. Maybe what we can do is non-deterministically keep reading characters and then choose to read W2. Then non-deterministically, you see what my finger's doing, right? Then read W3.
So that makes sense. How do you do that for an arbitrary n values? You can use the regex, right?
Well, a regex might cause problems, but well, this is a string in L, and we assume L is regular, so L has a
DFA.
But we can arbitrarily just choose like a length and just make it NFA and make the assumption of when do a DFA of say. And then
I don't know what you mean, make a length.
Like pick length n, so W1.
Well, you don't know what the length of the string is going to be. The supposed super sequence is going to be. Non-determinism. It helps.
How many times do you look up doing the exam and see this?
It happens more than you think. Yeah.
So I have another quick question on problems, question 1.
Question 1. Okay.
Yeah. Would this, just for my own curiosity, would each transition be a combination of A, B, or C being 0 or 1?
Yeah, because if you're making a DFA, it'll have all 8 possibilities. So it'll have 8 transitions.
So each state's going to have 8 transitions
Yes.
to.
If you're making a DFA. If you make an NFA, because dead state,
Right.
do you need the transitions to a dead state? No. So you're good.
And that's because like, the length of the tuples, because there are 8 possible.
Yeah, because I have 2 choices for each of the 3 cells. Mhm.
But on number 1, you're not. Well, on number 1, it says DFA, or can you make an NFA? And it can be a problem?
Well, I said prove that A is regular.
Oh, okay, cool.
Something that really helps and will help you on the midterm, read the question.
You titled it DFA though.
Yeah, that's what I intended. Because I want you to get in the process of understanding how to make the deterministic machine first. Then work with non-deterministic machines, as we'll do twice more in this class. Actually, one the other way around, but other questions? Yeah.
So because we're dealing with binary, we only have to worry about the other zero carry and 1 carry.
Mm-hmm.
And whenever we go to the dead, we don't want to leave.
Yeah, we don't care because it's never going to be a valid addition anyway. Mm-hmm. That's a great idea. If you have base k, then you'll need k minus 1 states for the carry bits and then 1 steady state. I haven't thought about that. Actually, another way to prove that languages are not regular is in the last question, the optional bonus, where we want to find the minimal DFA. If you can prove that the minimal number of states for any DFA for that language is infinite, it's not regular. So I won't say what it actually, the real result is, but I want you to think about how do you minimize the number of states in the DFA. And that actually can implicitly prove that some languages are not regular. It's a pretty cool result, though. Other questions about anything, really? Oh yeah, sure. Yeah, questions like that are absolutely welcome. Do a quick power set construction. Now I don't remember which one I should do. So I'll make one up. Q0, let's say it loops on this guy, loops goes to here. Okay, so here's a NFA. Oh, what the heck. Let's add more. Okay, I think that's sufficiently complicated. All right, so if I want to make a DFA for this guy, what should I do? Put a start state. So remember, we got to look at the epsilon closure of the start state of the NFA. So what's the epsilon closure of Q0? Q0 and Q3 because I can't get anywhere else other than those. So make that a start state. And we'll worry about final states at the end. All right, where can I go on symbol A from 0 or 3? Q0, Q1, Q2, and that's it. On symbol A. So Q0, Q1, Q2. Those are the places I can get to on symbol A. Now, what is the epsilon closure of 0, 1, 2? Well, it must include 0, 1, and 2, but do I include 3? Yeah, because I'm in 0. So I better go to include Q3 in this as well. The name of the state is not important, but it is important for us to understand what the state represents, but the DFA doesn't care what the name of the state is. All right, let's see where it goes on symbol B. So where can Q0 or 3 go on symbol B? Yeah, so it's going to go to the empty set state because we're unioning over 2 empty sets, which is empty set. So I better go to a state called the empty set, and like we did before, this guy is going to loop on everything. And not accept, of course. Okay, Q0, Q1, Q2, Q3. We're not done yet. Where do I go from A on every single state? Well, I include Q0, Q1. 1 goes nowhere on A. 2 goes to Q1 on A, so we include, yeah, Q2 goes to Q2, and that's it. that's it so far. But now I got to do epsilon closure, include Q3, but we already have that state, so I'm going to make that a self loop. I think this might accept everything. No, it doesn't accept everything. So where does this go on B? So Q0, Q2 for sure, Q1 goes there, and that's it. So then we got to include Q3 because we're going to do epsilon closure. So we don't have that state, so we need to make a new state. Actually, I'm going to make Q3 not final. Yeah, I'm going to make it not final because I wanted to make it more interesting. All right, so we're going to make this new state on symbol B. Now, 0, 2, 3, where can I go on A? So 0 and 1, so Q0, Q1, let's keep track. Q2, where's it go on A? It goes to itself in Q1, so we got to include those. Q3 on A already includes Q2, so now we got to do what? Epsilon closure, and is that going to add Q3? Yes, always. So we have that state already, so we're going to come back. Okay? What about on B? Q0 goes where on B? Nowhere. Q2 goes where on B? Q0 and Q2 has two transitions. Q3 goes where on B? Nowhere. Not a dead state until we determine it's the empty set at the very end. Well, we include Q0, Q2, so we're not empty. What's the epsilon closure of 0 and 2? Q3. So do we have that state already? Yes, we do. So we have B there. Yeah. So then now how do I determine what's a final state and what isn't? Anything that has Q1 in it. And this looks like the only winner. Okay? Does that make sense? Okay. Yeah.
Is it okay to use the notation star for that state to say like all?
You have to be pretty clear about that, but yeah, you should be pretty clear about that. Yeah. So the language of this thing is not quite so easy to describe in English. Yeah. It's the set that you currently have. No, I'm unioning all the places that you can go to via epsilon transitions. No, so we had the example Q0, Q2 to start with. Then we added Q3 because Q0 can go there via epsilon. And so now we add that to the list of things that you could reach. And so that now becomes the state name, Q0, Q2, Q3.
Right, but you said the epsilon closure of Q3, I thought.
I don't think I said that. Did I say that?
Yeah, I thought you said.
I don't think I said that. Yeah.
Can you go over a pumping level problem?
Can I ask a question real quick?
Yeah, go ahead. Mm-hmm.
Let's say we have another state from Q3 to like Q4 or to Q2 on epsilon, so we include Q2.
So like if this had a epsilon transition there, yeah. Like at the very start state would be Q0, Q3, Q2. Yes. Mm-hmm. Yeah. So everywhere you can reach, otherwise on epsilon. Yeah. Other questions about this? Okay.
So that is an epsilon on that.
No, she asked a question about what if we included that, but that's how it was originally defined. Other questions? Okay, pumping lemma question. So I'll answer one that was on Piazza that I put as a daily exercise. So W in 0, 1, 2 star. W has more 0, 1 substrings than 1, 0 substrings. If this was instead over 0, 1 star, it's regular. But if it's over 2 star, it's not regular. Pretty interesting. If I made it over 0, 1 star, how would you tell what the language is? Well, if it has an equal number of 0, 1 and 1, 0 substrings, every 0, 1 matches with exactly 1, 0. 1, 1, 0. And so therefore, can the ends of the string be different characters? No, because it would make an odd number of alterations between 0 and 1. So if I made this over 0, 1 star instead of 0, 1, 2 star, then this is actually the language of where it's the same character, it starts and ends with the same character. So that's regular because it's in the problem set. But so clearly I'm not going to do that one, but for obvious reasons. So let's do this one. So if I include 2 in the alphabet, it becomes non-regular. Why? Because if I have 0, 1 followed by a bunch of 1s, then the next thing better be a 0 in the 0, 1 case. But if I have 2, then I've lost that information about 0, 1. And so therefore, that's not a proof, but that's just an intuitive idea. So I claim that L is not regular. And let's see if I can remember the proof. So if I want to claim it's not regular, what do I do? Assume it is. Took on a new whole persona there. All right. Assume L is regular, then what? There is a pumping constant P for L. Yeah. So there exists a P for L. Yeah. So next thing is choose a string. So what 2 properties of the string must we have? It's in the language and length at least P. Very good. No, not has more, sorry. It has an equal number. If it's more, then it's still regular if you had 0, 1. But if it has an equal number. So now we got to choose a string in the language that has an equal number of 0, 1 substrings and 1, 0 substrings.
0, 1, star. 2.
No. So if I did this, so if I did 0, 1 to the P, well, so this whole string will eventually not work. But let's see if we try this. Well, if I try this, then that has P 0, 1 substrings, but how many 1, 0 substrings? P minus 1. So I could add a 0, but that wouldn't change anything. So I got to introduce a 2 there. But then I still have fewer 1, 0 substrings than I need. So what if I did it in reverse? Would this work? No, this would not necessarily work because if y happened to be exactly 2 characters and I removed it or added it, then I'm going to still have the same number of 1, 0 substrings because the first half of the string looks like this, right? And if I remove 2 characters, I'm going to remove a 1, 0 and a 0, 1 substring. So it's still going to have the same number. So that's not going to work. So this string is, don't do that one. What if I can force the 0, 1 substring parts to be on the left side and the 1, 0 parts on the right side. So what do you think I should do this time? Exactly. Try this. 0, 1, 2 p times, then 2, 1, 0 p times. So now I've made sure that the 0, 1 substrings are in the first half of the string, and there can't be any 1, 0s in the first half. And similar for the right side. Okay? Oh, yeah. So this one is actually pretty interesting of the proof. Well, what would you do for any decomposition? Why? What would seem like a good idea? Well, if I put more characters on the left side, that has a chance of increasing the number of 0, 1 substrings over here and keeping the 1, 0 substrings, the number of them, the same. And therefore I have an unequal number. What if y was only a 2? That's not the only case. But what if y was a single 2? And I've tried to put more 2s into the string.
Remind me why? Y is like the final
Yeah.
x, y, right?
Yeah, so we're thinking of this as x, y, z. It's the part that we're trying to, so the term is pump in or pump out. So putting more copies of y into the string to hopefully get out of the language. Well, if y was a single 2, and I put more 2s on the left side, that wouldn't change anything, and I would never leave the language. So if y was a single 2, what should I do? What if I removed it? That would increase the number of 1, 0 substrings. Because if I have 0, 1, 2, 0, 1, 2, etc., if y was the single 2, and I axed that guy, then the 1, 0s would go up on the left. So I'd have 1, 1, 0 substring on the left and the same number on the right. But I didn't increase the number of 0, 1 substrings. Okay?
So then it'll be 0, 1, 2 to p minus 1. 0, 1.
Yeah, I don't know exactly what this, yeah, so a way of dealing with these is not worrying about what the actual string is at the end. It's worrying about the number of each substring you're working with. Okay? So let's see. Well, what if, so a similar thing might happen here. Would that happen? So the case I was wondering about is if y was exactly a multiple of 3 characters, which could happen. Then what should I do? What if I remove that 2, 0, 1 from the left side? The number of 0, 1 substrings went down. So would I leave the language now? Yeah. Oh, what if I had any character on the left side? Well, if it was a 0, if the y part had a 0 and I removed that 0, what would happen? The number of 0, 1 substrings went down. If it had a 1, any 1 did the same thing, the number would go down. If it had a 2, same thing. So no matter the decomposition of W into X, Y, Z so that Y is non-empty and X, Y is within the first P characters. Consider X, Y to the 0, Z. So remove Y from the string. So that's also XC. Removing any character on the, so I'll be informal, first half of the string. removes at least one 0, 1 substring, but does not change the number of 1, 0 substrings. And therefore, xz is not in L, so L is not regular. It's pretty cool. So I thought we'd actually have more cases than this, but you can actually be informal like this by saying no matter what the decomposition is into x, y, z, such that you have the two conditions, remove the y part or pump in a y or whatever, and then consider what would happen. If you removed a 0, then the number of 0, 1 substrings went down. Same for 1, same for 2. Yeah.
Do you have to talk about the choosing for individuals, like break it down into like a subset?
You should. Yeah, because, and you have to talk about every decomposition.
Right.
Yeah, because if one works, that might be the one that works for a possible DFA. So if everyone doesn't work, then you're all set. Other questions? Yeah.
I'm not clear on exactly that explanation. If you pull out the 2,
Mm-hmm.
that doesn't
Oh, yeah.
the 0, 1s and add 0.
Yeah.
That's the same
Well,
thing.
yeah. So except for y equals 2, that's the only possible other case. Because if it includes any 0 or 1, removing it will remove it.
Right.
But if you remove 2,
So you have to specify that second.
so yeah. So if y equals 2, then number of 1, 0 substrings goes up, but number of 0, 1 stays the same. Yeah, yeah, thank you for fixing that. Yeah.
For 3, is it possible to come up with the DFA right off the bat, or is that not?
You'd be a madman if you did, somehow. Yeah. Well, actually, it does say construct an NFA for it first. I mean, you could, but then I made this from pure thought. I wanted you to get the exercise of doing the power set construction. That was the goal. But if you somehow came up with it, I guess that's fine. Yeah. Yeah. It should be a lot of states, though. It shouldn't be really trivial, though. Yeah, test small strings. Yeah.
So for 4 and 5 on the problem set,
Yeah.
it involves proving that, so one language is defined using another language, and then it involves proving, well, if the language that is used to define this language is regular,
Yeah.
prove that that language is regular. Could you do a problem with that exact same, that's the question to the problem, and just to see like what the process is for that, not using those exact problems, but
Sure. So let's consider this. So I'll be even a little bit more informal. Okay. So here's a language. It's the union of two things. One of them is W contains 0, 1 as a substring, and we know how to make an NFA for that. And another one where it's just a set of all strings with odd length. Okay? Could I make a DFA for both? Yeah. So is L regular? Yeah, why? Yeah, so we know how to make that's regular because we know how to make an NFA for that and easily. And this is also regular because this is a DFA. We can easily make a DFA for that. So L is regular under what? Closure under union. Yep. So if you prove that both parts are regular, say the 3 words, closure under union, you're all done. Yep.
If we were to do a proof like this on homework, we'd have to actually make an FA or DFA, right? Or can we just say that there's this?
Well, it depends. If, like, on problem 4, where it's dependent on L, there's literally no way you can make an actual DFA for it, but you know a DFA for L exists. So if you can make a modification for the original things so that you make a DFA, NFA, whatever, you're fine. But if it asks like a specific thing, like contain 0, 1 as a substring, and it says produce an NFA for L or show that it's regular, then you make the actual thing. But if for some reason, if the question said prove that L is regular, then like in this case, you would make an NFA and DFA for both, like NFA for the first, DFA for that, and then say closure under union. But if it said produce a DFA for L, then you would need to convert that thing to a DFA, then do product construction. Like it's actually making you do the thing. But if you, making you do the thing. But if it just says prove L is regular, then you just need to, yeah. So there are actually some interesting problems where you only know the existence of a DFA, but we don't know a DFA exists. I'll actually show you a cool example. So let L be either one of 2 strings, 0 or 1. So I'll invert them. So it's 1 if life is ever found on Mars, otherwise 0. One of those 2 will always be true. I don't know which one. In both cases, it's a single string. Can I make a DFA for whatever one it is? Yep. I don't know which outcome it is, but I know a DFA exists for it. Yeah. Well, no, I know it exists.
Well,
Yeah.
Exists for one of it or for L?
Well, whatever, L is one of those 2 strings. I don't know which, but I know whatever it is, a DFA exists
So
for
you're not
it.
saying L is both?
No, it's one of those 2 possibilities. Mm-hmm. Yeah.
So it's like just having a DFA ready to go, and if at any point life is ever found on Mars.
No, it's not like the DFA is ready to go. It exists, but I don't know what it is. It's pretty weird. Well, all you need to know is that it exists. So like a lot of the constructions for some of the things I'm researching, you can actually prove that this object exists, but you have no idea how to make it. Something called a probabilistic method, but yeah, so something like this is pretty cool. Any other last questions?
Other
Because
things
we're almost.
are provably not
What?
construct, like something you can prove you cannot construct. Right? Still exists.
Yeah,
So
something.
that's-
Exactly. Other questions?
Have you ever found another substitute for the alpha stylus? In the event that you forget it and everybody knows
It's too perfect.
it is. That's what it is.
The irony is Steve Jobs hates stylus.
Yeah, it's not a stylus though. Any other questions?
It's an extension of grammar.
Okay, I'll see you on Wednesday.